We're going to start our new unit by looking at ratios. And today we're going to be looking at the language of ratios. But before we do that, I want to talk about going camping. So let's imagine that you and your family of four are going to go camping for 3 days. And you packed some camping gear. You've got a tent, you've got sleeping bags, you've got sticks to make a fire, you've got plenty of water, and you've got some sunscreen. So, what I want to do is I want to make a relationship, I want to make a comparison between some of the items. So, I might say you have one tent to four sleeping bags, or you have three bundles of logs to two sunscreens, or maybe you have four pillows for four people. And that's all we're doing is we're making a comparison. Now, when we talk about ratios, a ratio really is making a comparison between two different things. Our definition of ratio is an expression of a relationship between two or more quantities. Now, that sounds fancy, but really it just means you're comparing some things. So, for our example, if we have a class where there are 11 girls and 8 boys, the ratio of girls to boys is 11 girls to 8 boys. We're just making a comparison. Now, we can write ratios by using the word to. We can write them with a colon, which is the punctuation symbol that is two dots on top of each other, or we can write them as a fraction. But no matter what, we always say our ratio as 11 to 8. You can just replace your numbers with whatever numbers are in your problem. Now, one big thing with ratios is that your order does matter. So if our ratio for this example problem is 11 to 8, it is always talking about girls to boys because that's what the 11 means is you have 11 girls and the 8 means you have 8 boys. If you flip those numbers around and you said 8 to 11, that changes the ratio. It's not the same. Even though you're working with the same numbers, it's a different ratio. Now, we have two different types of ratios that we're going to be working with. The first is a part to part ratio, and these compare just parts of a problem to another part of a problem. So, for a simple example, we have two circles to five triangles. These are just two parts of the whole set of shapes. We broke it into two separate parts. Now, you also have part to whole ratios, which compare one part of the whole thing to all of it. So, for example, we could say we have five stars to six shapes. So, the shapes is the whole group, the stars are just a part of that group. Now, in the real world, you have ratios everywhere. Nature is full of ratios. We see it in our galaxy, we see it in plants and flowers and storms and animals. This is what we call the golden ratio. It's probably the ratio that shows up in nature the most. It shows up in our architecture, so buildings like the Eiffel Tower and the pyramids. You can look at the golden ratio like it's a square or a swirl or a set of lines. So it's everywhere, and even art like the Mona Lisa or the Great Wave, and even SpongeBob SquarePants. So first, I want to look at some part-to-part ratios. In this case, we've got a calendar where we looked at weather for a couple of days. And first, we want to compare our rainy days to our cloudy days. Well, all I do is I count my rainy days, and I've got one, two, three, four, five, six, seven. And I count my cloudy days. I have one, two, three, four, five. And I write that. And again, I can write it either as a fraction, I can write it using the word to, or I can write it with that colon punctuation symbol. So I have 7 to 5 because I have 7 rainy days to 5 cloudy days. And I would do the same thing with sunny days to rainy days. I would count the different weather patterns for each day. And so in this case, I have 2 sunny days to 7 rainy days. Now, sometimes you may see both. You may see both part to part and part to whole ratios in the same type of a problem. So, in this is a survey of a band class where we are looking at flutes, tubas, saxophones, and xylophones, and the number of students that play each. So, saxophone to tuba, that is a part to part because we are looking at just saxophone and just tuba. And in this case, we have a 6 to 5 ratio. Xylophone to flute is also a part to part. We have 3 xylophone players to 8 flute players. Tuba to non-tuba is a little tricky. It's still part to part because it is not all of this total instruments, but it's a different kind of a part. So we have 5 tubas to 17 non-tuba players. So we would just add every student up except the tuba players. And then number 4 is our part to whole ratio, because we just want to look at the number of saxophone players to all of the instruments. You might see total or all or the complete. That's kind of your hint words. So in this case, we have 6 saxophone players to 22 total instruments. That's the overview. It's going to be something that we have to practice. And if we had to summarize it, ratios just compare things.